Hi everyone, I am the founder of the Grey Blind Owl. Today we will learn about scopes with you. What we will cover today will be quite easy to understand next to what we have covered before. So far we have defined our variables and used them specific to a single field. However, defining our variables in different places and in different ways can provide us with various advantages. Although I thought it would be more appropriate to use a slide for the introduction of this topic under normal circumstances, going through a code directly below will allow us to avoid drowning you in extra details. We include our library hashtag include stdio.h. Program scope global variable out of any function. These are our keywords for this variable, okay? This variable is valid for all your code files in a project. It is known by the other files in a project and we can use it in them with the same name, okay? It is known by the other files in a project and we can use it in them with the same name. Here, if I define here an integer I is equal to 15, a variable actually, I can use this variable with the same name in here and in here. And I do not have to define these variable again and again in these code files. But it is not recommended if it is not strongly necessary. If it is not strongly necessary because its cost is expensive for our processor. Okay, it is not recommended because its cost is expensive for our processor. Okay, this is global variable and this variable in program scope. Now, I will mention file scope. File scope out of any function and with static. This the important keyword is static here. This variable is valid for only this code file, not for all code files. Okay, this is valid for only scopes.c code file, not untitled 1 or untitled 2. Okay, only scopes. So static integer j is equal to 3 and semicolon. This is our file scope variable. Now we create prototypes for our functions. This part is not important because I used these functions to show the scopes to you. Okay, void function and semicolon, void print semicolon, void fixed duration semicolon. I will explain these functions later. We create our main function, integer main, and the brackets and the curly brackets. And now we create two integer variables, but I was already defined before above. I is a global variable and its value is protected. Okay, these variables now block scope variables, and these I does not conflict with other i's. These I does not conflict with other i's. These I in this block and this I variable block scope variable. Okay, block scope variable, not global variable here. Okay, for loop with the block scope I, for I is equal to 0 and I is less than 3 and I plus plus and k plus plus and semicolon go to print again and semicolon. This is function scope. Okay, this is functions and print again our label. And as you can see, I did not define j in this block, so we use static integer j is equal to 3 and semicolon that we defined before above. Now we print the variables, execute, compile, and run. Now, here, as you can see, our I is equal to 0 our j is equal to 3 and our k is equal to 6. K in this block, so k is known in this block again, so we can use the k here. Also, j a file scope variable, and we can use the file scope variables in everywhere in this source code file. Okay, source code file. So we defined here these variable static integer j is equal to 3, and we can use it in this block. And also I is a block scope variable again, and same with k, and we use the I here. Now I will use a function now for the some exercises. Function and semicolon. Now go to the function. We define two variables here. Integer k is equal to 10 and I, and semicolon. Actually, you know that the k, this k is different from this k. Okay, this k is different from this k. So this k belongs to this block, and this k belongs to this block. So for I is equal to 0 and I is less than 3 and I plus plus, again block scope automatic duration integer a is equal to 4 and semicolon. Block scope, this variable belongs to this block, and it cannot be accessed outside its block. Okay, it cannot be accessed outside its block. So if we use this expression outside of this block, we cannot reach the a variable because this variable belongs to this block. Okay, now as you can see, function k is equal to 10, a is equal to 4, and I is equal to 0, because block scope, not global variable. And now here print function, we go to the print function again. Here the value of global I is protected. Printf I with program scope, the person sign d I. We print here these I. Okay, we use the global variable in this function. Okay, printf I with program scope, the person sign d I. As you can see, we did not define any I here, and we can use the global variable in this function. Also, I can use the global variable in this code file and this code file if they all belong to the same project. Okay. So as you can see, I with program scope is equal to 15. These I and these I are completely different. Okay, now I is equal to 1, and our for loop is continuing to print these variables, and function k is equal to 10, again a is equal to 4, and I is equal to 1, and I with program scope is equal to 15 again. As you can see, this is stable, and these I increased here. And again, I is equal to 2, and I with program scope is equal to 15. Okay, we print the global variable in this function, as you can see, integer main function. So again, I with program scope is equal to 15, and this means our global variable cannot be changed by the functions. Our global variable is valid for all functions and all program. Okay, now fixed duration function. We go to the fixed duration function here. What is this fixed duration? We use automatic duration. We have used automatic duration so far, but we can use fixed duration also. Fixed duration here, static int fix is equal to 2 and semicolon. This is block scope variable, and it has fixed duration. Now I increase our fix variable, fix plus plus and semicolon, and printf fix is equal to the person sign d fix and semicolon. So our fix is equal to 3. And now our function has finished now, and we use it again. We use it again here, fixed duration and semicolon. Now we go to the fixed duration. Static int fix is equal to 2, and fix plus plus. Normally we can say that fix is equal to 2, so fix plus plus, and our fix is equal to 3 again. Printf fix is equal to the person sign d fix, so 3 and semicolon. But here 4. This is wrong or not? This is not wrong, because fixed duration provide us a memory. Okay, our fix is equal to 3 now, because here our fix goes to the 3. Sorry, our fix went to the 3, and our fix will not create it again. Okay, will not create it again, because static int means if our fix changes, if our fix is changed by any factor here, x plus plus, for example, we remember their old value, and we do not set again 2 as s2. Okay, so our fix is equal to 3, and fix plus plus is equal to 4, and printf fix is equal to the person sign d fix, so 4 and semicolon, here 4. Okay, if we use it again, fix duration, fixed duration and semicolon, and it will be 5. Actually, we know that, and execute, compile and run. As you can see, fix is equal to 5, because the old value is here 4. Static int fix is equal to 4 actually, but we use these 2 as an initial value. Okay, and fix plus plus, our old value is equal to 4, so 4 plus plus is equal to 5, and printf fix is equal to the person sign d and fix, so 5 and semicolon. As you can see, fix is equal to 5. Okay, that's it for this week. We finish our program here, return 0. Today we learned about the states of variables and their different definitions. Next week we will continue with pointer functions, another structure that will make it easier for us to use functions as parameters. Thanks for all your effort and patience. See you following lecture. Stay tuned.